Welcome, everyone, to this week's podcast. This week's guest is Shane Frankenfield, my brother. He has a Bachelor's of Science in Materials Joining Engineering from LeTourneau University. From there, his first job was with Chicago Bridge and Iron in a 2-year rotational engineering program. So we'll be talking about his degree, his experiences, the jobs he's been through, what it takes to get there, and everything you want to know about materials joining and what you can do with that degree. Shane, thanks for coming on the podcast.
Yeah, thanks for having me. Looking forward to it.
Yeah, so I guess let's start with, us in high school. What encouraged you or led you to materials joining? How did you find that?
I think really what it came down to was, both of us kind of grew up in the farm setting, right?
Yeah.
And then kind of the construction background from, the jobs that dad's had. And so it's one of those things, kind of always enjoyed the welding, the fabricating side of things. And then I always heard the stories of, high paid labor jobs, or like welders always making good big money. And I just wanted to kind of take it, what's the next step besides just kind of being like your welder, right? And so actually our high school superintendent, Dr. Sheard, introduced me to LeTourneau University and the particular materials joining program they have there. And so I just kind of set my mind to it, and that's kind of the career path I decided to go with. I've enjoyed it so far. It's definitely given me a lot of different opportunities and a lot of variety as well. That kind of sums up what got me started there.
Did you get a materials joining engineering tech or materials joining engineering degree?
So yeah, this was a technology degree. Looking back, I wish I would have kind of pushed myself right off the get-go. Getting out of high school, and be honest, I didn't really care about grades, education. Gonna be pretty straightforward. I was probably not ranked the highest to succeed after graduating if you were to poll my peers, right? So, and because I didn't really care. Like, high school just seemed so meaningless, really, to me. I was playing sports, enjoying those type of things and extracurricular activities. But once I kind of got into college, I was a little more focused. I actually cared. I felt like I had a path. I had direction. I could kind of see a little bit into the future with opportunities, right? And so, I just set my mind to it. I was focused on and interested in learning what the teachers were actually teaching, instead of just, abstract literature that I didn't, felt like any application, or just random historical dates, which ironically enough, I'm actually pretty interested in history right now. But, I did pretty well in college, if I had to be honest with myself. And I wish I would have kind of pushed myself a little bit farther right off the get-go, because I was a little bit hesitant, because I never really pushed myself academically. And so I decided to go with the engineering technology degree. And it's, a little more hands-on, and there's a little more labs involved. Not quite as many core math classes as the traditional engineering program at LeTourneau. And so I kind of wish I would have pushed myself a little bit more there. But to be honest, that decision there thus far has not really affected my career path, after college, to be honest. So it's more of a personal regret, I guess I have. Just wish I would have, maybe accomplished that. But career-wise, it really hasn't held me back in any way that some people might think it could potentially do. So.
Yeah, that's one thing. Cole and I have talked about it a lot, about looking back at high school and how, I don't know, in high school, I thought, high school is so important. And then, like, looking now, it's like high school is meaningless. High school, they don't teach you anything valuable in high school. They don't like
Right.
They don't teach you about investments or the stock market or
Right.
alternative ways of making money. They don't teach
Passive
you about
income.
taxes, anything that's beneficial, I feel like.
No, absolutely. And yeah, I guess you really wouldn't get that in college either, unless you're focused on a business major, I assume. Speaking with some of my other colleagues that kind of focused in on different career paths, it is one of those things. It's a shame we aren't exposed to more of that stuff. But in reality, I think an engineering degree in general, from what looking back, what my degree taught me to do was learn how to learn. Right? It's actually something that a lot of people don't have a skill of learning, and I know it kind of seems kind of basic, but looking back, that's what Laterno and my degree taught me. Right? Learning how to learn. And so if you have that simple basic skill and you apply it well, honestly, you can do anything. You can, make up from the shortcomings of high school and them not teaching you your taxes and how to handle that, or investments and things like that. And so I don't know. That's why I'm a big fan of just engineering degrees in general. I mean, I can only speak specifically for the welding engineering degree or materials joining, whatever you want to call it. But I do highly, hold engineering degrees, in my opinion, they're as very valuable.
No, yeah, I agree. I think they teach you, just basically problem solving, how to think, and then with that you can go in and tackle any problem, even if you haven't been necessarily taught it. So at Laterno in the materials joining program, I'm pretty sure, but I believe Laterno is one of the only schools that offer that program, correct?
Yeah, that's correct. Basically, you have your main two choices right off the gate would be Laterno University or Ohio State. Somebody out there is going to probably correct me. The Ohio State.
Yep, exactly.
I don't. I worked with a couple of Ohio State grads that were in their welding engineering degree. I'd like to think my Laterno peers, I think we far exceed the Ohio grads that I've been in contact with. No offense, you are out there, but
Savage, just calling people out. Right.
Seriously,
watch out. Watch out.
What if we try to get Ohio State as a sponsorship?
Ooh, that's gonna be tough. Hey, have you hit up Laterno yet?
We haven't. I think Cole's got a couple contacts that we could reach out to hopefully maybe get some people on the podcast.
Yeah, I don't know who's even there anymore that could help us out. But
Cole, what's the name of the assistant dean or
assistant or the provost?
Yeah,
Dr.
the pro.
Mason.
Yeah, Dr. Mason. We got to reach out to him.
Dr. Mason. Yeah, give him a call.
Yeah, I should.
But
that was my sister because she was a good student.
Yeah, so
going back to your original question, you have Ohio State and Laterno University, and then you have some of these other schools that are starting to, they see the niche of materials joining engineering. That's what Ohio State and Laterno call it, and then some of these other schools offer welding engineering degrees, which essentially, if you break it down, is basically the same thing. So the schools that offer welding engineering degrees would be your Colorado School of Mines, Ferris Tech or Ferris State, I believe, offer a welding engineering degree, and then also Penn Tech, Pennsylvania School of Technology. I believe that's in Williamsport. They offer, they kind of offer a modified welding engineering degree. They kind of have like a 2-year associates, and then you can up and turn that into a 4-year bachelor degree in welding engineering. And as far as like ABET accredited schools, I don't know where. I know Ohio State and Laterno definitely are. If other people are interested in looking into that, I just don't know really where. If they're ABET accredited for the same type of discipline, that'd be something worth looking into.
Is that something that's valuable you found thus far in your career, that magic ABET accreditation?
No, absolutely. Like that's the one kind of standard from all my applications, or when we're looking to hire additional employees, it's that ABET accredited. You keep seeing that over and over and over, and that's kind of seems to be the standard. So,
yeah, that's what Cole and I, when we interviewed Josh Workman and Ben Keeners, or I guess not necessarily Josh because he's computer science, but he spoke on a little bit about computer science and engineering, and Ben spoke about mechanical engineering, and Cole and I with mechanical and biomed. It's that magic ABET accreditation,
right.
And it's
Yeah.
we talk about after the podcast we want to start an accreditation company to get paid to go around and accredit.
Yeah.
For no particular reason at all.
Yeah, exactly.
Like, we want to.
Yeah, just go around picking apart these colleges' lesson plans and I guess their structure, right? What else do they really do?
Well,
Your course sequences is
course
I think
sequence.
the largest one.
Don't get me started on course sequences.
well,
What
even
a joke.
In the hospital environment, there's the Joint Commission that accredits hospitals. If you don't have the Joint Commission accreditation, then hospitals, Medicare and Medicaid won't reimburse the hospitals.
Wow.
Yeah, and so, they get paid to come in and just accredit hospitals every year. Like, I want to set up my own accreditation firm.
Yeah, yeah.
So back to Laterno in the materials joining program. Could you just give us a breakdown of some of the classes or labs that you took while you were there?
Yeah, sure. The first semester, I think all engineering students, regardless of discipline or engineering versus engineering technology, I think most of them are pretty basically the same as far as your engineering classes are involved, right? You have your, I guess, engineering, and I forget all what we call those classes, but engineering 1, intro, engineering
intro
2,
to engineering, yep.
all that stuff, and it's just basically making sure you can follow instructions is what it boils down to, right? And
right.
then, following that, I guess we all got involved with like SolidWorks, like a basic SolidWorks class, which I think is, industries overall are kind of really heavy in modeling or 3D modeling. So I think that was valuable there. And then it kind of rolls in over to, your statics and materials, materials of enginering, your, statics, dynamics,
materials,
right? And then, that's what I think. All your mechanicals, all your civils, all your materials joining majors, we're all required to take those core classes, right?
Right.
Right. So, and then, we all had to take chemistry. That was a pretty tough class, the chemistry. I think I had to do more with the professor there, but
that's a weed out class. They love to make it hard on the freshmen to take chemistry. Sucks.
Cole and I both failed a chemistry test, just to let you know, Shane.
Really?
Yeah.
So bad. And we thought we passed. We celebrated.
We took the test and then went to Chick-fil-A because we knew that we did so well on that test. And we both got like 50s, I think.
No, you got a 50. I got a 36 or some crazy thing. It was the lowest grade I had in all of school.
Cole, please tell me that you scored way higher in a couple tests than Jake.
No, never.
Never?
Statics.
No.
I schooled Jake in statics.
Yeah,
All right,
you always did better in statics, and you did better in fluids, I think.
Fluids.
No, remember you were like that one test. You were like, Cole, I held my paper up, was hoping you would look at it because you did it all wrong.
Yeah, maybe or may not have done that.
Yeah.
No, Shane, Jake would have had a 4.0 if it wasn't for me. Like, I was the anchor. I was holding him back.
You were holding them back. Jeez, that's crazy. But what was your GPA, Cole?
3.25 maybe or something.
3.25. Yeah, nice.
Something like that.
What was yours, Jake?
3.8 something.
Yeah, good job.
What'd you have?
Mine was a 3.73, I think.
Oh.
Yeah.
I don't want to hear none
And
of this
that's-
good job for a 3.2. 3.7 student
and
over
that's
there.
the thing. Looking back, I wish I would have took the engineering courses, I guess. And so your engineering technology and see what it would have done. But hey, we'll never know.
Well, so the difference between those, was it just Calc 3 and differential equations?
Essentially, that's what it boils down to when looking back through the classes. Because even, as the material joining majors, you start getting more involved in the actual discipline, right? So you have fundamentals of materials and fundamentals of materials joining. So there's a lot of labs. It's very heavily lab weighted, because you're in the lab, you're setting up welding process equipment, how it operates, the variables, digging through the power supplies and how those function.
Right.
And then, you get into a little bit to, cutting processes and like how those work. But then you also get into a little bit of robotics, which is pretty neat. Because, there is a lot of automated welding equipment out there. So Letourneau did a fairly decent job at trying to bring the students up to speed on automated welding equipment. And so you got to do a lot of programming, which a lot of people are probably surprised, like, whoa, welding engineers programming? I mean, it's basic programming, welding robots, which is, it's not like any other programming software that I'm aware of anyways. But
well, is that mostly like G code, or is it just like a different user interface?
So yeah, it would be similar to G code, like CNC machining, right? It would be similar, I guess, code to that, programming logic like that, which is kind of basic once you get into it. So then, we also get into your welding engineering degree, kind of get into some of, once you've actually made your welds, right? How do you know they're acceptable? So it kind of gets into non-destructive evaluation, so you really dig into magnetic particle testing, penetrant testing, eddy current, ultrasound, and like x-rays, right?
Did you get to do x-rays in school?
We didn't actually have an x-ray booth or anything like that in lab, as you can
just
imagine.
Shooting x-rays at people?
As you can imagine why. But we review film, we go over things like that, and just get everyone exposed to what typical things you could see. Well, because kind of every NDE method that you go through, you can only really see a little piece of the puzzle, right? There's no one NDE method that just like, hey, wow, you can see absolutely everything 100%, and it's okay, right? It's always multiple NDE methods paired together that for your final buy off on certain types of welds. So it's kind of
and
neat.
Just to clarify, NDE is non-destructive evaluation.
Correct. Yeah.
Okay,
so you have your NDE and then NDT. So NDT would be non-destructive testing. So testing is more of like the guys like hands-on in the field doing the actual testing. And then, a lot of times those guys will also evaluate. And then sometimes, particularly with, specifically X-ray, you have X-ray technicians that will do the testing. Then you'll have a different personnel that's a little more qualified to actually do the reading of the film and evaluate what's acceptable and what's not.
Okay. Gotcha.
So they kind of give you a brief overview of what to expect there. And one thing I wish they would have really kind of dived down into a little bit more is, every industry, oil and gas versus manufacturing versus power generation versus, even bridge building or, maritime vessels, we all have different types of acceptance criteria, right? And so someone that's not in the industry may not know that, it's like, oh, a good weld's a good weld. Well, a good weld, it may be acceptable over here, but you go to nuclear construction, I guarantee you, it's going to be, thoroughly reviewed inside and out multiple times, right? Versus your standard, feed mill construction or something like that, where it's like, hey, airtight, that's all that really matters. Make sure it doesn't leak. So it's, within one industry, there's a large variety of what's acceptable and what's not. So.
Yeah, it makes sense. I mean, we deal, like at the power plant where I've worked, we deal with thousands and thousands of PSI, of thousands and thousands of degrees of steam. Like those welds need to be perfect or
Absolutely.
really bad stuff's going to happen.
Yeah. And so kind of on the flip side of what you're talking about there, you're talking about high heats and high pressures, right, Cole? So the specific project I'm working on right now, which is kind of neat, we're building a liquid natural gas LNG tank. And so it's kind of a little bit of the opposite there. We're storing liquid product at negative 320 degrees Fahrenheit. And so instead of high heat and high pressure, we're extreme colds. And what happens to your steels at extreme cold is they get very brittle, right? And so there's a lot more, I should say a lot more. You're developing your weld procedures for these type of applications, and your NDE methods are very thorough because you're operating at extreme low temperatures where your steel typically gets very brittle, and so you have to, as with any application, you need to be very kind of specific with the materials and welding consumables you choose and your NDE methods for specific flaws, right? Versus your high heat input or your high heat applications may be very different for what you might be looking for.
And so this is where in school all of your materials classes were very important, so you knew how the material itself would react in different pressures, temperatures, and different situations, right?
Yeah, I would say so, I guess. I mean, it's such a high level of what you go through, I felt like, where maybe they briefly talked about it, maybe it just didn't solidify. And now that I'm specifically working in this industry, you see a little bit more of the big picture, and you actually have to go through the practice of, what's your application, going through and developing weld procedures for your specific application, and going through the code books. And that's something I think, when I specifically went through, I think from what I've talked with the other students that have graduated, they're doing a little bit better job at LeTourneau now, is educating the students to the applicable codes that are more broadly used in the industries. And I think that's really important. That's something that wasn't really heavily hit when I was going through, because everything's based off these code books for the industry you're working in, right? Everything is based off of that. That's kind of like your Bible that you go to. And so, you may be a good engineer and understand materials very well, but if you can't go back to your code book and base off all your decision making and your thought process off your code book, you're not really applying your knowledge, right? So I think that's an important way to tie everything back together, and that's something that you learn in your industry, right? Every industry is going to be a little bit different here in different areas, and you're not going to graduate boom and ready to go, right? Dive into API 620. For your cryogenic storage vessels or whatever, code books that you follow at your power generation stations, Cole. I'm honest, I haven't been exposed to that, and I'm not sure what you guys follow.
Yeah, I don't really do a ton of it, so I've been lightly exposed.
Oh, dang, okay.
Cole's right now is working in like data analytics almost, right?
Really?
Yeah, that's where I'm currently at. During my internship, I did quite a bit with I'm a weld inspector out there, and I'm pretty sure most of the code was B311.
So that would be process piping, right?
Mm-hmm. And
or power generation piping.
And then there's another code specific to the boilers, like high pressure steam boiler, and like the drum, but I can't remember what the name of that code was. But it was
probably like ASME Section 9. Most likely, or Section 8, ASME Section 8.
Yep, that sounds right. Yep.
Okay, so I guess back to you took all these classes, you graduated LeTourneau, and I know it's at one point in there you took not an internship, but a co-op with Harley Davidson. Could you tell us a little bit about what you did in that co-op experience?
Yeah, absolutely. That was a pretty neat experience that I was exposed to. And that was a co-op at Harley Davidson in Kansas City, Missouri. which they actually no longer have that facility there. And they closed down that facility, moved everything over to York, Pennsylvania. But yeah, my specific role there was kind of like a welding engineer in the fabrication department. So basically, what Harley had set up, they kind of outsourced all their, their raw materials, right? So you get your blank steel stock. They would either, bend the tubing elsewhere or, cut it into the shapes that you need. So they kind of like send us little Lego pieces, right?
Okay.
And so the fab shop basically would take these little pieces here and there and load them up into our weld cells and, weld your bike frames out or weld your fuel tanks out and kind of process them through the line. Then they would go to paint. Then they would go to detail. And then they just work their way all the way into assembly and out the door. Excuse me. So my specific role there was just really kind of, first few months was just kind of getting, acquainted to everything. It's, that was my first time really in a manufacturing environment. So this is a huge facility, right? And going right in, a little bit overwhelming. You're trying to get your bearings and there's just so much to take in, right? So, I think that's one of the things that's super valuable versus an internship versus a co-op. Your internship, probably half your time in your internship, you're just getting acquainted to the systems and how that company's works. And, there's just so much to take in that you really can't be useful and valuable and really start to learn and develop a certain amount of skills. But like halfway through your internship, and then you're just getting comfortable, boom, and then you're back to school. Where I really enjoyed the co-op because I kind of got through that little bit of a learning curve, that learning stage, and then the last 6 months, I really felt like I was actually adding value in our fabrication department because I was involved with some cost reducing some programs there, so like. It shows you the importance of just tracking all your metrics, basically, cycle times for your parts going through different stations and your wasted time or your wasted parts that, come out defected and basically tracking scrap, right?
Right.
So I was able to get involved with some cost cutting measures there and kind of go through their system on how you track waste and things like that. And so I was able to make a significant improvement on a couple of their actual bike lines. So I'm not really sure how much I can say about all this stuff with, Harley Davidson. So this might be a little bit of a gray area. But anyways, so some other neat things that I was able to do was actually at the time that I was there, they had some really old automated welding equipment. And so at that time, they were bringing in new weld cells and just bringing those up online in the facility there. And so I was kind of able to head up a few of those things and just really, hit the ground running, working with some of the guys on the floor, some of the operators, some of the welding technicians, and, kind of bringing these weld cells up to speed so that they would, have higher capacity, better quality, reduce cycle times versus the old weld cells, right? Really trying to bring them up to speed and just get them going. So that was something that was really neat and getting exposed to. And,
So
yeah, go ahead.
I was just going to ask, so these new automated welders, how many automated welders are we talking? Like, are we talking like 50 or are we talking 5 that can do like 100 bike frames a day?
Yeah, so the way they have it set up, and it's really up to your manufacturing engineers or your development engineers, whatever they have in mind. It's really kind of unlimited what your options are. But specifically at Harley, they had all the welding machines broken down by bike model, essentially.
Right.
So you have a couple weld cells that would work on, say, your V-rods or your soft tails or your other models. And so now they did have a few weld cells that would do like a set of 3 different models. And
Okay.
and that was kind of their idea, because they wanted to be able to adjust to like what the general population was kind of pulling at. So they wanted to be able to bring in one weld cell, and you could run 3 different types of models, or you could do one type of model and triple your output essentially, right?
Right.
Mm-hmm.
So it was really neat, just the whole overall experience. Getting involved in a manufacturing environment, what that's like, working with that particular workforce was a union workforce. That was the first time I was exposed to anything like that. So, getting accustomed to how those guys operate, which is a different speed than some. But
It's like the VA.
I can only imagine them.
We got a union rep at every meeting.
Really?
Well,
So what particular union is the VA hospital
it is
represented by?
AFGE, the American Federal something.
AFGE.
Yeah. Let me see what that stands for.
And they only represent like what type of workers? Where does that cut off?
The American Federation of Government Employees. So all government employees.
Oh, really? So then, are you technically? Are you joined?
So I am a bargaining unit employee, which means I can be represented by the union. However, during my orientation, I can opt out of joining the union and paying union dues. However, if for some reason I got in some argument with my boss, the union, if I wanted to, still has to represent me.
Really? Even though you're not paying any dues?
Correct.
That sounds like a pretty good deal.
Yeah.
Well, I mean, it's like,
but you're free. Yes, I do.
So I mean, that's I don't see them win a whole lot of cases though. So, they're suing the I don't know who they're suing now, but they want all federal, or I don't know, they have some language about federal employees getting hazard pay for the COVID-19 pandemic, but I don't think that's going to happen.
Oh, really?
Yeah.
I know some of our refinery workers in our area down here in Louisiana were getting hazard pay. Sound like a pretty sweet gig.
Well, I know my neighbor who works at Sheetz, he got hazard pay, and it was $4 more an hour. And I said, I work at a hospital, and I do not receive hazard pay.
Yeah, that sounds a little messed up to me.
Yep.
Interesting. So, all right, with opting out of the union, were you also did you weigh the options of opting in the union and looking at the pension plan they offer?
Well, I mean, I already have a pension with the federal government.
So well, you're set regardless. Good for you.
Anyways, back to your story.
Where were we at?
First time working in a union environment.
Oh, that's right. That's where we got off on that tangent. So anyways, I think some of the neat things at Harley, I guess I learned from that experience was can't get along with everyone, specifically, union employees. At that point in time, I thought, hey, I can just get along with anyone. Sadly mistaken. So, following that up, actual related to things that you can kind of gain value from, and where you need to pinpoint areas of improvement in a system is tracking specific metrics, and they showed me the importance of that, where if you can set up a standard set of metrics and track it consistently over an extended period of time, you can look back through your system and see where your waste is and go back and pinpoint that and make improvements. It's super analytical, unbiased, and an easy way to find errors in your system versus having this is really where we need to improve. this is how we can save money, or someone's opinion is like, no, we got to go the other way with this. And so that was the first time I was kind of exposed to really just tracking. And that sounds basic, but tracking, wasted time, specific types of outputs in your system. And so that was something that I really valued. And I try to bring that with me, like now in my kind of career that I'm doing now, is like, how can we set up new metrics, which is something, it's kind of a little bit different in manufacturing engineering versus project-based type of applications. A lot of things are uncontrolled, and it's really just try to get the job done as fast as you can, staying under budget, under hours. So there's not a lot of metrics that are tracked in project-based type environments. And I think, a lot of people are trying to change that, and I think it's a very, very valuable thing to do. But so that was one of the things that I valued working at Harley. And then
how long was your co-op at Harley?
So that was essentially a 9-month co-op there. Yeah.
Oh, okay. I didn't realize. I guess I didn't remember it being that long.
Yeah, no, it was, maybe it was 8 months. It's probably 8 months. So it would be more accurate. 8 months, I think, then. So, yeah, because it was like right after Christmas to the end of August, I think. That's what it was.
Okay.
Yeah.
Gotcha.
Yeah. So, and so, when I was working there, I was going through, I kind of set up my course sequence, right? I didn't really look at the sheet because whatever. I set up my courses so that I could take as many online classes as I possibly could at my co-op. So while I wasn't at school, I could still set myself up to graduate at that 4-year benchmark versus, having to take a semester off and then, now I got got to take a semester after my 4 years and all that nonsense,
Right. I mean, that's very similar to what I did. I tried to do 18 credit hours every semester up until my senior year, basically, and then took many online classes so that I could schedule to get a co-op and still graduate on time. And I think it is extremely beneficial.
Yeah, and that's called making your own luck. You know what I'm saying? It's taking your life in your own hands, sprinkle, I like this, sprinkle a little bit of want to, A lot of people don't have any want to. Gumption.
Yeah, we're getting into the heart of it now.
I know.
Preaching, Shane. Preach.
We'll start a different podcast called Shop Talk.
But anyways, people, and sometimes, a lot of people enjoy it. I specifically this is not what my focus. It was to have a super, super senior year, right? I was getting in, getting out, trying to make some money. And, like you just said, double up on your online classes, give yourself some flexibility in your course sequence, because we all know your advisors aren't there to help you. At least mine wasn't.
Shane, that brings up an excellent reason why Cole and I created this podcast, because we felt like, high school counselors, school advisors really don't.
They're just like the federal government. Always there to help a lending hand.
Well, see, this is the part that's hard for me is I don't feel like I meet very many people that feel like they're not very helpful. Like, it seems like there's this little group of people that I wasn't in that got help. Like, there was always people like, oh yeah, that's Linda. She gives me all the classes I want. And I'm like, I'm out here in the cold, not getting any of the classes I want.
Where's my Linda at?
Yeah, where's my Linda?
Yeah. Hey, Cole, you're your own Linda. Let me tell you right now.
You're darn right I am.
Yeah.
All right, so Shane, after you had that Harley experience, you finished college. How did that Harley experience shape you? I guess your desires and the career path that you wanted to take when you were looking for jobs after, or I guess during your senior year, to get started working as soon as you graduated?
Yeah, so that's a good question. While I was working at Harley, I was asking as many questions as I possibly could to the younger engineers there that I thought were succeeding. Obviously, this makes maybe not be clear, but don't ask people that are just kind of chilling, hanging out.
They got that glazed look in their eyes.
Yeah. Pass right by those people. If you're really wanting to step it up the notch. Talk to the young engineers that are moving up quickly. Talk to some of your senior engineers or your senior managers or your younger managers. What are they doing? Ask them questions. Just ask them questions, because you honestly know this. You don't know what you don't know, and it's hard to even ask good questions when you just don't even know what to ask. But you got to be able to develop conversations with these guys, and that's what I did, right? So I was talking to engineers, talking to other engineers that are moving in or moving out. There's kind of a transition period while I was there, and so I was able to kind of speak with some engineers that were always just involved in manufacturing, right? And then I was able to speak with a couple of our new engineers that were a little bit older in age, and they were kind of coming from, the oil and gas industry, right? And so you kind of like an unwritten kind of culture maybe I saw. Now, this may not be, a blanket statement for everyone, but kind of what I saw was, you're a good manufacturing engineer, right? Where you're going to be kind of a good oil and gas project engineer, kind of in like that sense, right?
Okay.
Because these, unless you're a process engineer in typically oil and gas, but like from my experience and the type of work I'm involved with, right? An engineer in the manufacturing environment, you have a complete control of everything. Where out on project base, you're going out into a patch of dirt and you got control of nothing, right? You don't have control of the weather. You don't have control of anything. So I think it was a different mindset. And so I was able to kind of talk to these guys and get a feel for that. And honestly, at the end of the 9 months, as much as I did enjoy my experience there, things kind of got stacked. You're making the same bikes, the same, X amount of bikes every single day. You have your same little fires you got to put out every single day. And it gets old. It kind of got old. It got boring. And I didn't like the fact, especially in the winter months, I went in at 5 o'clock or 6:30 or whatever it was. I left at like 5. And I thought, like, oh my gosh, I did not see the sun at all today. You know what I'm saying? And I'm like, that's not good. I'm a little depressed. So that's kind of like, I need to get, hey, engineer, you're always going to be working at a desk, right? But, if you're on a project, you can go out and work on the project and be involved in that area, right? So the position I have now, yes, I have, responsibilities and paperwork and a lot of things you got to handle at your desk and on your computer. But there's not a single day that I'm not running out to the field and working through some problems and going through our processes and where we're at in our construction sequence to make sure we're staying on track and moving forward there. And so it's a lot more dynamic, right? It's not just the same gadgets you're making every single day, right? And so that's kind of what I was able to kind of ask the right questions and knowing kind of like myself and how I like to do things. So yeah, Harley helped me kind of decide I didn't want to work for a manufacturing style environment, right? And so kind of after, graduation or during my senior year, going through applications and going through there, kind of narrowed it down with Chicago Bridge Iron. We had some legacy guys at the school that spoke really fondly of CB&I at the time, and so I was able to set up an interview through the career fair. I don't know if you guys talked about career fairs before on the podcast, but sometimes it can be awkward. You're going around just talking to a bunch of strangers, but hey, that's how I got my job. Super helpful, and it's one of those things where face to face is very important. I think able to land a good job. Everything's, especially now with COVID and all that stuff, everything's on the line or over the phone or Skyping in, which I'm sure I had any Skype interviews. I know, Jake, you were telling me you had five or six Skype interviews. I just feel like that'd be kind of tough. I don't know. I never had to do one.
I've had I think 3 Skype interviews. Yeah.
Okay.
One of them was like, hey, here's a SolidWorks file. Dude.
So, all right, be honest with me. Out of those 3 Skype interviews, were you wearing pants to any of them?
No. So
all right.
No. I always dressed up. Always.
Oh, come on. Just the top
Because
half, right?
the guy always said, "Hey, I'll call you," and I didn't know if he was going to Skype me or call me, and he switched. The first time he called me, the second time he Skyped me, but I was prepared.
There you go. Yeah, but you're sitting at your desk, right? You don't technically have to wear pants.
Yeah, but I'm not taking any chances. You know, the computer falls, you lose the job.
Anything can happen. I got you. I like it.
Yeah.
But so yeah, that's kind of how Harley shaped me, and that specific co-op experience, and what I was looking for in a career right out of school. I'm gonna be honest, there wasn't at that time. I felt like, and speaking with a lot of other graduates in my degree in my program, job market was kind of tough. So, I had multiple interviews, and I honestly only had the one offer with Chicago Bridge and Iron as well. So, I kind of had, it was up in the air. Was I going to wait it out, wait for something else, or run with it? So I decided to run with it, and I've enjoyed it since. A lot of neat experiences, a lot of neat people. Learned a ton since I've graduated and started with the company. So it's been a good experience.
That's good. So the first position for Chicago Bridge and Iron was a 2-year rotational program, correct?
Yeah, that's correct. So they called it the engineering training program, or what do they call it? CBI training programs. They called it CTPs, right? That was kind of the name they slap on your back as you're going through the company.
I got TCF, so.
Did you? TCF?
Yeah. They just affectionately call us the rotators.
The rotators.
You're a rotator. You're temporary.
Rotator. That's funny. So yeah, that was it was valuable. It was kind of tough in a sense, but yeah, I can go over what that was like. So essentially, day one, I reported up in Chicago, in Plainfield, Illinois, and it was kind of like orientation, and ran through some training there essentially. And I was up there for about 4 weeks. Then I moved down to Houston, Texas. That was where one of our fabrication facilities in Houston are, where we do a lot of our fabrication for the Gulf Coast area and a lot of the eastern side.
Okay.
So everything from Chicago Bridge and Iron, a lot of people, if people don't know, we build large storage vessels essentially for municipalities, so for water or for sewage treatment, and then we get into oil and gas, so petroleum-based products, raw crude oils, all the way to your refined products as well. So we build spheres, which use typically like a butane or a propane. These are, if you've ever driven by a refinery, you may not be looking for them, but they're there. These large, looks like a giant basketball on stilts, essentially, made out of 2-inch steel. So that's what those are. And then you have large, storage tanks. And for example, this specific type of project I'm on right now, we're building I think they are the largest full containment LNG tanks in North America.
Really?
So it's 200,000 cubic meters.
Wow.
You could go ahead and do a quick conversion on gallons. I know it's probably 50 million gallons if I'm right.
Good
We'll
Lord.
just go with that.
Yeah,
That's
it's
so big.
very large. It's they're basically 300-foot in diameter, so a football field in diameter, and to the top of them they're 170 feet tall.
Wow.
So yeah, and that's just my kind of personality. I like big, right? Big, impressive. You're driving by the road, driving along the road one day, your kids in the car or your friends yeah, I built that. No big deal. You know what I'm saying? It's impressive. It's just sitting out there and it's going to be around for the next 100 years. You know what I'm saying?
I get
it's
that
just
a little bit, Shane.
permanent, and I take pride in that.
Yeah.
You know what I'm talking about, Cole?
I changed the landscape.
I don't start the stuff, but to say you work at the power plant that has the big stack and turns everybody's lights on, there's a little hey, no, yeah, I know what's going on.
I'm a part of that, exactly.
Yeah.
Exactly. So, that kind of feeds my ego,
I just
guess.
saved people's lives. No big deal.
Yeah, there you go, Jake. Thank you. No, I'm not. But anyways, so yeah, no, and that's. I feel like I went on another tangent. Yeah, I did go on a tangent. So going back to Houston, I was in Houston, and so I was in that fabrication shop there, kind of going through our fabrication techniques, what we do specifically, how we do it, learning the product line from the get go, and then from there I shot over to Beaumont, Texas. It's a nice little place and tucked away over there in southeast Texas.
That's my favorite part of Texas.
Yeah. A lot of people might overlook it, but she's a gem. So food is amazing. You can't ding them on the food. They got that nailed down. Anyways, in Beaumont, Texas, I was working at a large storage field. Essentially, we were building crude oil tanks, 250-foot diameter, floating roofs. That's what they call them, floating roof tanks. So essentially, you have a giant steel roof that sits directly on top of your product, and it goes up and down as your capacity increases. So I was there for about 8 or 9 months there.
What's the purpose of the floating roof? Is that for like
floating roof
condensation?
is to prevent, you don't want basically minimizing the air contact with the product, right? You're losing product, it'll evaporate, emissions, and all that good stuff. And because it's the most economical way to do it, essentially. Those are super neat tanks. Because those were larger diameter tanks, so they're pretty in depth. It takes roughly 6 months or so to build a tank from start to finish, based on your work crew, your performance, and how much the customer's pushing is kind of what it comes down to. But so from there, I went to Asheville, North Carolina.
Right,
that was probably
area.
Definitely by far my favorite place in all the rotations I went. Food also very good, but just gorgeous atmosphere outside, the landscape, the mountains, the waterfalls. Like, hey, what do you want to go do this weekend? Oh, just go hiking, chase waterfalls and all that good stuff. Go float down the French Broad. Yeah, that's a good river, let me tell you. They have it's a very neat atmosphere. The city's pretty cool. So that was by far my favorite rotation. And specifically what we were doing there was building a natural gas power plant, a combined cycle natural gas power plant. So our scope of work, is that the power plant you guys are operating out there in Phoenix?
We have a lot of them. We have simple cycle, which is just a gas turbine, and then also combined cycle. And so we have a little bit of everything.
So that was pretty. Now, like, our scope of work was strictly just the storage tanks there. So and Cole, correct me if I'm wrong or if I stray, but in the power plant you have the actual process side of things. But you also have like these large storage vessels, demineralized water. You have fire water. You have diesel storage tanks, right, to kind of get the system going or whatever they use the diesel for. So those were kind of the structures we were responsible for building, and then we also built the smokestacks. Those were like 170 feet tall. We built 2 of those.
I forgot. They're just steel on gas plants, right?
Yeah, the ones we did were just carbon steel. They had a special type of coating on the inside that was like ceramic base, which was kind of interesting. But that's when I was able to kind of and that's just taking advantage of the opportunities where you're at. Even though our scope wasn't anything to do with the actual power process side of the project, I was still able to talk to a lot of those engineers and just kind of learn like how that overall system works. So that's where I learned, what a combined cycle power plant is versus a simple cycle, which is kind of neat, and learned what a HRSG is, which is just, what is that? correct me if I'm wrong, Cole, but heat exchange. Basically, it's just like a. What's that?
Heat recovery her
Generation
heat
system.
recovery generation system. Yeah.
Yeah, exactly. Right. So it's just basically you have your combustion system, and all those hot exhaust gases go into like a boiler system, right? And that boils and creates steam and runs another generation system, right?
Yeah, and so in a 2x1, there's 2 gas turbines that heat one system of water.
Oh, okay.
That heats the water to steam and then turns a steam turbine, and those are more common because they're more efficient.
Oh, really?
Mm-hmm.
So I don't think ours was a 2x1. I think it was just a single combustion, yeah, and then a single steam to another generator.
Yep, those definitely exist. We have some of those in our fleet.
Okay, cool. So yeah, like the overall scope of that project was to replace a coal power plant that was existing right there because of all the nasty things coal does, right? So
no, wrong. Coal is great. I love it.
You like coal?
I don't know how political we can get on here, but yeah, I definitely do. I don't think it's quite as bad. I worked at a coal power plant for my internship, and so I learned a lot about it, and I think it's probably...
Coal ran around in the coal piles.
In the ash pits? Ooh, gross.
Yeah, so... Yeah, I did.
I heard the ash was pretty nasty stuff.
It's just dust.
Really?
Yeah, but you're wearing a respirator the whole time.
Yeah, I mean, you know... concrete, like the dust that's in concrete,
fly ash.
Yeah, that's what it is. It's from coal power plants, and so it's no dirtier than dry concrete.
I heard. Well, yeah. Don't just say that, because silica, is kind of becoming a new asbestos. Essentially, if you look that up, like people grinding on just concrete, if it's not wetted in like specific industries, a lot of people will have a cow because they think the silica is super bad. I don't know. Maybe it is. I haven't done my research on that.
Definitely need to wear a respirator. I mean, I did when I was in the fly ash, obviously, because you don't want to inhale it. But it's not. Yeah. It's just dirt.
And I kind of heard there's starting to be a premium on fly ash because a lot of these coal plants are either reducing capacity or getting phased out. So there's really not an abundant source of fly ash to just pull from now.
No, yeah, because we used to sell that. I didn't realize it was a sold product, the fly ash. And so as coal plants close, it's going to be in shortage, and it's not like, it's going to be more expensive. It's going to be, we need to find something else to put in concrete.
Right. Yeah.
Wow.
Yeah, that's a kind of a unique little story. We had some fly ash on our project here, where we had one source and they ran out, so we had to go use a different source. And for all our concrete, we had to do different batch tests to, validify this other fly ash source. And yeah, sure enough, there was a little bit different characteristics, and we had to kind of change up our batch mixtures a little bit to get the right strengths and the slump that we wanted. So
it's very interesting.
It is. So anyways, from Asheville, I moved up back to Chicago to finish up my final extent there in Plainfield, Illinois. That was in our weld lab. And so going there, basically my scope was, learning how to write weld procedures and run through all that, kind of really digging into the code and what's required to develop weld procedures and specific NDE methods, so that they're acceptable for different types of product lines in different environments, right? So say we may have a crude tank down here at the Gulf Coast. Very rarely do we see temperatures lower than 30 degrees right on the Gulf Coast.
Right.
So take that same storage line, the storage product, carbon steel, essentially it's a carbon steel tank. You move that up to, say, Minnesota. Weld procedures will be very different than the same weld procedures you're using on the Gulf Coast, specifically because you have extremely low temperatures. So we develop our weld procedures for that specific type of environment. And so, it's kind of neat. And then, like I said, like our weld procedures for our cryogenic tank we're building right now. are very, very different than even that tank in Minnesota where it's carbon steel, but it's still not getting below negative 65, right? Well,
Right.
our cryogenic tank's getting down to negative 370 degrees Fahrenheit. So they're going to be very different as well.
Do you have to pre-stress those, Shane?
No, there's no pre-stress for that specific type, and really in welding, large welded structures, you want to minimize all the stress you can have. A lot of times, what will actually happen specifically on our spheres, like these large diameter spheres that are very thick, like say 3 inches thick, they'll go ahead and weld all that out, right? You'll have your vessel basically complete, and so when you're welding, you actually induce stresses in the materials, which are bad, right? Say you're going to take this vessel up to 300 psi. Well, this material already has a bunch of stress in it from welding it. So how do we fix that? Basically, we take this 90, 80-foot sphere, wrap it in insulation, and take a giant blowtorch to it, and we'll take the entire vessel up to like right around 1100 degrees. We'll hold it for about 4 hours, and then we'll slowly bring it back down. And so what that allows it to do is take all those weld stresses that are in that vessel and relieve them, right? You bring it up to a temperature where we all know if things get hot, they lose a little bit of strength, right?
Right.
And so you're able to relieve some of those stresses. And so your goal is basically bring it up to that temperature, bring it back down. All your weld stresses are out of it. And so when you pressurize it up to 300 psi, there's no additional stresses there, right? Where you could potentially have a failure. Mm-hmm. So, stresses in materials as far as welding concerns is something we try to avoid. And that goes by basically what's your product and your type of material that you're using. So
you're making me want to switch jobs, Shane. Your job sounds so much more interesting than mine.
It is an interesting job, and there's a lot of nitty gritty to it, and it's a lot of, that's all the theory, if you will, behind it, and then what actually happens out on the job site, and that's like the battle, right? This is what we need to follow. But hey, we also got to make money and build it as fast as we can, right? So that's where managing it all so that we are building a good product to our code requirements and making money and staying on schedule and appeasing to our customer. And, it's a neat challenge that there's a lot of moving parts and pieces, and there's a lot of people involved. And it's pretty rewarding, kind of getting to play all your fronts, so that we all have that same goal at the end of the day. Coming home with a big pocket of cash.
So after you left that, the 2-year rotational program, and then now you're at this job down there in Louisiana.
Yeah.
What is your technical title? A project engineer, or what is your title?
Yeah, so I think, let me kind of back up and finish, not to keep dragging this on, but, kind of going back to creating your own luck that we were kind of talking about earlier. So the 2-year, you got to sprinkle a little bit of want to on it. You know what I'm talking about, Cole?
Oh, dude, I know what you're talking about. Don't want to.
So the 2-year training program is, it's just that. It's 2 years, right? But it was very loose, right? And so you really get out of it what you put in. And so my entire time going through, I could see it wasn't really getting managed properly, or the way I thought it should have been managed, right? Mm-hmm. Dates were slipping, things were getting behind, and I'm like, all right, this is not going to work. I'm not going to be done in my 2 years, right? Not that I wanted my training to end, but I don't want to have a training title for 3 years in my career, right? You know what I'm saying? Right. I want to get done with my training. I want to get my title. I want to earn that, right? I want to be fully responsible for what I got going on. And so that last rotation, really the last 2 rotations, I kind of started trying to push things along, try to move things along and escalate things to really get that 2-year mark. Because there were some other trainees that we all kind of started together, right?
Right.
And there were some other trainees, they told me stories of like, their manager called them and it's like, hey, so, how's Louisiana treating you? All this good stuff. Are you enjoying the area? He's like, well, you know what, Bob? I've been in Texas for about the last 3 months, so on a different project, and stuff like that. To me, that bothers me, right? So It's really, hey, taking your own fate in your own hands and making something for it, right? And so I kind of moved things up, sped things up, and so from transitioning from the training program to my position right now, it's important making connections along the way. I think that was something that's very valuable in the training, any type of training regardless, is making those personal connections with people. I found people that I saw excelling in their career, learning from them, establishing good working connections with those guys. And so that's essentially what happened, how I got in the position I'm in now. I went back to those individuals and said, hey man, I'm trying to push through this training program and this is my expected date. What do you have for me? Well, what's out there? What's out there for me to look forward to and, join your teams that you guys have, and what are the big projects? And so that's kind of how I transitioned to where I'm at right now. And along the way and getting involved with other people, I could see, the career path specifically for welding engineers. It's a good career path, don't get me wrong, but there's not as many options, right? You can get capped out. You basically, you're a welding engineer, then you can, be essentially a senior welding engineer, and then, you're a manager of the our welding department that we have, and that's maybe you can get into be a quality manager on a specific project or a specific area in the company, but that's essentially I saw like it kind of being a limiting factor, and so I felt like I had a good grasp on everything, and I kind of wanted to explore a little bit of different options, and so that's kind of where I started leaning more towards the construction production side of things to get more exposure and how the actual project is run, right? How
Gotcha.
Are we maintaining schedule? How do we get materials on site when we need them? How do we have the correct personnel? How do we have the correct equipment so we can be profitable, stay on track, and build a good product, right? And make money. And so I just saw that you have more options, you have more availability. Say I want to stay with the company, well, there's more of a clear line for advancement and more gains and more potential, right? Versus sticking on the welding engineer path. I'm not dinging it by any means. I enjoyed it fully when I was going through the training program and getting exposed to everything like that. And so I feel like I could always fall back on that if I had to, if I needed to, right? Or say I decided to transition to a different company. Welding engineering is kind of as a niche, really. Unless you have your certain manufacturing facilities. Some of them have welding engineers, but they're more. They call them manufacturing engineers. It didn't really excite me, and
Right.
so. But you always have project engineers. You always have project managers, construction managers, right?
Yeah.
Pushing the project, pushing the schedule, and seeing the overall picture. And so those are the skills that you can take anywhere with you through any company, and really I think apply them anywhere you need, and to be successful. So that was kind of my deciding factor, and kind of pushing and trying to slightly change and focus somewhere else in the company, and so that's kind of where I'm at right now. So
Okay. No, yeah, I mean that definitely makes sense because in all engineering fields, you're gonna reach a cap as an engineer.
Exactly.
And then at that point, you're gonna have to decide if you want to go into some sort of management role It's basically your next step in that progression.
And yeah, oftentimes that's a big step, and not everyone's cut out for it. I'm not sure if I'm completely cut out for it, if I want that type of responsibility, managing a bunch of people that are moody and irrational at times, right? And
people,
so
bunch of people.
Well, managing projects is one thing, or managing equipment or like a process, but then you start throw those darn people in there. And
it gets complicated quick, doesn't it?
Throw that union in there.
Ooh, I gotta stay away from that. So, but yeah.
So this project down in Louisiana. So this tank you're building at that temperature, what type of material is this tank made out of?
Yeah, that's a great question. So, I can give you a little bit overall structure of specifically LNG tanks. Maybe too much depth, but might bore you guys. But anyways, so specifically what I said earlier, these are the largest full containment tanks in North America. Essentially, when they say full containment, that means you start with you have a concrete. Well, let me start over. You have 110 foot concrete piles, going into the earth, right? Because we are in the swamp. There's nothing underneath. So we have 110 foot concrete piles, 1,300 of them per tank, right?
Wow.
So it's, has a secure foundation. You basically have your concrete slab, and then you build a carbon steel tank outside. And that carbon steel tank gets encased in basically like 3 feet of concrete, 2.5 feet, 3 feet of concrete over the entire thing. Right? And so you were talking about pre-stress and materials earlier, Cole. So our concrete actually does have, it's not pre-stressed, but they're post-stressed duct work all throughout the concrete. And so that'll kind of secure the concrete there. And then once all that's complete, you jump back inside your carbon steel tank and you build what is called 9% nickel. So it's mainly iron, but then it has its 9% nickel. And what that nickel does is it starts changing your grain structure from body center cubic. This is going back to your materials days. All right, I hope you guys paid attention. Come on, guys. So no, it changes your grain structure from body center cubic to a little bit more to the face center cubic. And so what the face center cubic grain structure does, it allows for materials, even in extreme cold conditions, still maintain ductility essentially, and strength and toughness. If you're going to really talk about materials, 9 nickel material is very tough. So those are the type of materials that we use, and that's essentially why, because we could build them out of stainless, but a stainless tank of this size would be astronomical in cost, and so that's what we fall back to, this 9% nickel steel.
Is there very much chrome in there, or is it just pretty much nickel and iron?
It's essentially just nickel and iron for the steel. Now, for our weld consumables, we use what's called a nickel chrome moly weld consumable. Yeah. And so you have your nickel. It's about like 50% nickel. Then you have about 20% chrome, and then you have some of your magnesium or your well, I don't know, it's not really magnesium, but your moly in there. And I'm not sure what the percentage of that is, and that gives you your toughness in your welding properties and your weld consumable for those extreme colds. And so that's essentially if you look at it, it's a giant Yeti can covered in concrete, right? That's essentially what it is. If you want to break it down, that's what we're building. The size of a football field, right? So,
good Lord.
It is very strange. You're walking in this structure, and it's like, your peripheral vision, you can't capture all of it, right? So it's kind of neat. We're pulling tractor trailers inside our tank here to offload the product. We can pull multiple tractor trailers in here. We have cranes inside the tank. We have all this equipment with plenty more space to spare. So it is a very large structure.
I get the other day I saw, I don't know if you sent it to me or if I saw it, I saw the video where they were raising the roof to one of the tanks that was just being completed. And
okay, did you see that on LinkedIn?
Yeah, that's exactly where I saw it. And so that was an air raising of the roof.
So yeah, that's a super cool process. That it's more, from what I've seen, it's kind of specific to storage tanks, right? They kind of adapted this construction method for these large vessels. Essentially, what you're able to do is after you finish kind of your bottom, you start your shell, right? That's basically your shell that holds the concrete and everything there. And once you get a couple of rings up on your shell, you're essentially able to start your roof down at the very bottom of the tank. Otherwise you would have to run your shell all the way to the top and then piece by piece, 165 feet in the air, start putting all these roof pieces up there. And, it just, you're working at heights. There's danger, there. It's slower. Anything at heights is slower and less cost effective. So what we're able to do, we're able to build this roof inside the tank on the bottom of the ground. The same time we're running our shell all the way to the top. So, you can almost plan everything perfectly. By the time you get to the top of your shell, your roof is very, very close to being able to, basically put into position. So, one of my roles in this here was essentially, making sure the roof is balanced, right? Because it's not just a roof, but it's also it has nozzles, right? It has a bunch of nozzles for pumping product in, pumping product out. And so, it's like a giant saucer that's unbalanced, right? So
It's floating. Yeah.
So, we have to bring a lot of materials in there, set them on the roof in a very certain pattern, certain position, certain weights, so that we can get our center of gravity, as dead nuts as we can. So when we start raising the roof, she doesn't want to start, this side's a little bit heavier, right? Start teetering over.
Good.
So
that's just scary to think about.
It's exciting. So, essentially that was one of my responsibilities, making sure all the materials are in the right spot, at the right location, at the correct weights, so that the overall mass of the roof is balanced, essentially getting a perfect center of gravity. And so once that's accomplished, you got all that, and you're ready to blow it, you essentially seal everything off, you get it airtight as possible, and essentially you just put these very, very large, I think we had one 80 horsepower fan, electric fan, and then we had on the other side, we had 8 40 horsepower fans, if I believe I'm correct. And, kick the fans on, and then it's kind of boring after that. It just...
Wow.
So the neat thing, really the most exciting thing is you'll have a small crew get inside the tank. You close everything off, right? Because you got to have, a good seal, and you'll radio out, hey, kick the fans on, guys, right? And so it slowly starts building pressure, and there's a seal in there. We got to make sure the seal's tight. So that's what the small crew's in there for. And as soon as the seal's tight, you're kind of watching everything, and the roof just slowly starts moving up out of nowhere. She starts floating. And once she's up in the air a couple feet, we'll all go out it's basically a cattle chute, right? You open up the one door, close it behind you, try to equalize the pressure, and then boom, walk out the other side. So it's, everyone makes jokes like, hey, the guys in the cattle chute, he's about to open the other door, open the other one on the inside real quick, boom, and launch him out, right? That's we don't do that. That's not safe. But hey, you could, right?
You could.
Oh,
What kind of pressure's inside that tank to lift the roof?
So this is kind of the neat part about everything. So the roof itself, this particular roof with all the weights on there to balance the roof, it weighed 1,840,000 pounds. Nothing too heavy, really.
Nothing serious.
And then, all right, I want both of you guys to take a quick guess. How much pressure do you think it takes to actually lift the roof up and float it to the top? Just take a guess.
I have no idea.
4 psi.
So it takes 7 inches of water. All right, convert 7 inches of water. That's essentially a quarter of a psi.
Oh,
Are you serious?
Yeah,
yeah.
Because
it won't take much.
it's such a large structure, right? You have so much surface area. You have a quarter of a pound per every square inch of this roof. She'll float right to the top. So
Yeah.
Wow.
it's
Didn't sound like a fool, so I went to 4. I was thinking like 1 or 2, but I thought there was just no way.
Yeah. No, that's what I was the same way. I was like, it's got to be, up there, right? You're lifting so much weight, but you run the calcs, and that's what it comes up to be. So, it's a huge milestone for the project. We basically did both of those about three weeks apart. It takes roughly to get it from ground level to the top of the tank at 150 feet in the air. It took like an hour. I think our record was an hour and 20 minutes. So, that sounds like a long time, but it's actually really, really quick. So
then once that roof floats all the way to the top, I'm guessing there's something that catches the edge, and then what do y'all like? I guess...
So there's basically, we'll have at the top, we had like 30 welders and fitters up there, right, ready for it essentially. And so, the roof will float up into place. It'll hit basically just another bar up there that's welded into place. It'll hit this, we call it a compression bar. It hits the compression bar. And then that's when the guys go to town up there essentially and, start welding and fitting as much as they can. And you constantly leave the fans on, right, to kind of help push up there, make sure everything's tight against that compression bar.
Right.
And, you may kick off a couple fans. And something that I didn't mention is we also have basically like a dampener, right? So say you want to slow the roof down for whatever reason, you can open up the dampener and let off a lot of the pressure, or you can, close it and speed things up, kick the fans on high. And so that's kind of how you regulate the rate at which you're ascending. So it's like I said, it's kind of a construction method that I'm only aware of, like large, tanks specifically used to, improve schedule, improve safety. You build everything on the ground as much as you can, and you blow it up into place. So something I was really excited to be a part of. It was something to see for sure. So
yeah, that's crazy.
Yeah, I mean that's insane.
Hey, that's just going back to I like big stuff, right? Big, impressive. I don't know. I take pride.
Are you still there, Shane?
Yeah, sorry, can you hear me?
Yeah, we can hear you.
All right.
No, that's insane. I mean, that is impressive.
Yeah, so that's kind of where we're at right now in our construction method, our construction process. We blew the roof for both tanks about 2-3 weeks ago, and so right now we're kind of moved to the inside of the tank. And we're starting our inner tank erection. So that's the 9 nickel material, which is, a lot of NDE involved with that, right? Because that's really our product barrier that's holding the product. And so there's a lot of code requirements on what's acceptable and what's not.
Yeah.
Gotcha. Well, Shane, I feel like we could have you on for a whole nother episode to go on way more in detail about everything you do. But since we're already over our allotted time, I'm going to ask our basic question is, what, through your experience and back when you were in high school looking to go to college, or even while you were in college in your program or in any of your jobs, at any point, was there something you wish someone told you that they didn't, that you felt like could have made your life easier?
Yeah, that's a good question. I think, what it really comes back down to, I think, we've kind of hit it a couple of times now, and I wish that maybe I would have realized it a little bit sooner, is you're honestly in control of your own fate. You're in control of asking the right questions. You're in control of creating your own luck. You're in control of making your own schedule. If something's slowing you down, there's always a way to, speed things up. If you're not where you're at, where you want to be, get there. You're in control. You know what I'm saying?
Sounds like you've been listening to Jocko Willink.
Well, and there's a quote that I really like, and honestly, I don't know who said it, but basically, life is 10% what happens to you, 90% what you make of it. Right? It's your choices. Right. We're all kind of dealt roughly. Not everyone. There's some terrible situations out there. But, between us three, I feel like we're all dealt roughly the same amount of cards, right? Mm-hmm. And, we're playing them the best we know how. And so I just think something that is important, going through college is, you're getting your education, right? But you're ultimately responsible for asking the right questions. You're ultimately responsible for taking the next step, going above and beyond what everyone else isn't doing, right? That's what's going to set you apart. And that's what's going to make you succeed and just, flourish in your career or whatever you decide to do in life. And so that's something I think, especially now, a lot of people are, hey, what can you do for me, right? Well, that's not going to get you too far, really, except for sitting at home, being miserable, or, go from there, right? I mean, I think, I'm kind of getting off on it. Nah, I'm not going to go there. All right, never mind.
That's for the second podcast.
Exactly.
Shop Talk will be coming soon.
Basically, to wrap it up, hey, if, you have goals, tell people your goals. I think that's another thing is you have something you kind of want to set your mind onto. A lot of people are more than willing to help you get there. You just have to voice that to them too, and that's one thing that kind of went through my training program halfway through. It was like, there's a certain set of things I want to do. And like I said, hey, you don't know what you don't know, but if you tell somebody what you're trying to do, oh, well, hey, I know how we can do that. Or, hey, I know this guy who can help us here, right? And so voicing what you want to do and getting other people involved, I think that's something that's important, right? And something I wish I would have learned a little bit earlier. So,
gotcha.
Yeah.
Hey, Shane. Well, thanks for coming on the podcast. I think we might definitely have you on for another episode later on to go more in detail about the project, or even find out once you complete it, everything that went through to get it completed. Thanks for coming on. Cole, you got anything else to add?
No, thanks for coming on. That was super interesting to kind of hear more. What a project engineer does. We've had a few office engineers, I would call them, on the podcast already. And to have somebody that's a little more hands-on with, just like you were saying, just giant stuff is really cool to hear.
Yeah. No, hey, I appreciate you guys having me on. It's been a good experience. And, I'd love to be on again. So hit me up, and look forward to hearing this on the air and all the other podcasts you guys have done so far. Looking forward to it.